Hey everyone, my name is Irfan and this project is called Task Suite. Task Suite is a full stack enterprise task and workforce management platform that I built to simulate how modern engineering teams manage projects, sprints, tasks, assignment, and collaboration in a centralized system. What I really wanted to solve with this project was the fragmentation that happens in many teams today. A lot of companies still manage work across spreadsheets, chats, disconnected Kanban boards, and manual coordination. That creates a confusion around ownership, visibility, sprint progress, and accountability. So I designed Task Suite as a structured workspace where managers, team leads, and team members can collaborate efficiently with proper role-based access control. From the technical perspective, this is a React frontend with a TypeScript Express backend, Postgres database, Prisma ORM, JWT authentication, and Cloudinary based attachment storage. Along with it, Dockerized local infrastructure. One thing I focused heavily was making the architecture production shaped instead of building just another CRUD demo. So throughout the project, I implemented RBAC authorization, sprint management, task workflows, file uploads, protected routes, pagination, filtration, validation, API testing, deployment workflows, and cloud storage integration. And I also tried to think about real engineering trade-offs around scalability, maintainability, and developer experience. In the next section, I will explain the system architecture and how all layers communicate together. Now let me walk through the architecture of the system. I structured the project into two major layers. The front end is built with React, Vite, TypeScript, Tailwind CSS, React Query, Juststand, and Radix UI component. The backend is built with Express and TypeScript, following a controller service architecture with Prisma as the ORM layer. And Postgres acts as the primary relational database. The reason I chose Postgres is because this domain is highly relational. For example, user belong to project, projects belong to sprints, sprints contain tasks, and tasks can have assignees. Tasks can also have attachments. So relational integrity actually matters here. Using Prisma on top of Postgres gave me type-safe queries, schema-driven development, migrations, and a strong relational modeling. One trade-off with Prisma enums is that schema changes need coordination across front-end and back-end. I actually ran into migration issues during development when role became inconsistent across migration and schema states. But honestly, that experience helped me understand real-world schema evolution problems much better. On the backend side, I intentionally kept the API stateless using JWT authentication. The authentication flow works like this. User logs in, backend generates access token, frontend stores this token, Axios interceptor injects token automatically, and auth middleware validates token on every request. And then authorization happens separately through RBAC middleware and service level permission check. The separation was intentional because authentication answers who you are, while authorization answers what you are allowed to do. For file uploads, I integrated Cloudinary instead of storing files directly on the server. The upload flow is frontend sends multi-part form data, multi processes the file buffer, backend uploads to Cloudinary, and Cloudinary returns secure URLs and metadata. Database stores attachment references. I chose this because managed cloud storage is much more scalable and production friendly than local file storage. For deployment, I use Docker for local reproducibility, Render for backend hosting, managed Postgres, and Cloudinary for media storage. This separation makes the architecture cleaner and easier to scale independently. Next, I will dive deeper into the backend architecture and explain how the APIs, middleware, and services are structured. Now let's talk about the backend architecture because this is where the most of the business logic lives. I structured the backend using a controller service pattern. So controllers handle request parsing, validation, status codes, and response formatting. while services contain the actual business logic. For example, task controller handles incoming task request. Task service contains task visibility rules, filtration logic, pagination, RBAC check, and update rules. I use this separation because it keeps the codebase easier to scale and easier to debug. The API itself is a version under slash API slash v1, and I split the route into auth route, task route, project route, sprint route, user routes. This makes the API surface very predictable. I also integrated a Swagger documentation so APIs can be explored visually through slash API dash docs. One thing I focused heavily was role-based access control. The system supports admin, CTO, manager, team lead, and team member. And visibility rules are enforced both at middleware levels and service level. For example, admins can access everything. Team members only see tasks related to them. Team leads can manage project specific resources. That logic lives inside task service and project controller. For authentication, I implemented JWT middleware. The middleware extract bearer tokens, validates JWT signature, injects user payload into request. Then role middleware handles permission enforcement. I separated this intentionally to keep the security model modular. For validation, I used Zod validator. So invalid payloads fail early before hitting the database logic. That reduces runtime error significantly and improves API consistency. Another important backend feature is attachment handling. I used Multer with memory storage because the backend is deployed on render, where local disk persistence is unreliable. So instead of saving files locally, Multer processes file buffer in memory. Attachment service converts this buffer and Cloudinary handles final storage. This design is cleaner and cloud native. I also implemented Jest and Supertest API testing. The test currently covers authentication, JWT protection, task CRUD, and authorization flows. While debugging test, I actually faced Prisma migration conflicts, enum synchronization issues, database connection problems, and Docker port mismatches. And solving those issues gave me much stronger understanding of the backend infrastructure debugging. Next, I will explain the front-end architecture and user experience design. Now moving to the front-end side, the front-end is built with React 19 and Vite using TypeScript. I structured it around pages, reusable components, API services, global auth state, and role utilities. One thing I tried to optimize was developer experience and scalability. So instead of putting everything into a huge component, I separated responsibilities clearly. For server state management, I used React Query. This handles caching, refetching, optimistic UI behavior, and invalidation. And for the authentication state, I use Juststand because auth state is relatively lightweight and doesn't require Redux level complexity. Routing is handled in app.tsx. Protected routes are enforced on the front end using auth guards and RBAC checks. But importantly, backend authorization still remains the source of truth. Front-end restrictions are only for the UX improvement. The dashboard layer creates a consistent enterprise-style experience across task, project, spring boards, workforce management, and profile pages. I also implemented filtering, pagination, search, drag and drop, sprint boards, task details models, and file uploads and avatar uploads. One interesting challenge was handling multi-part uploads correctly. Initially, attachment uploads were failing because multi-part boundaries were not being handled properly across Axios and Multer. I debugged that by separating Multer request from normal JSON request and ensuring form data was sent correctly. That was actually a very practical debugging experience because file upload pipelines are commonly tricky in production system. For forms, I use React Hook forms, Zod validation, toast notification, loading state, This improves usability and prevent invalid requests from even reaching the backend. I also tried to make the UI responsive and dashboard oriented instead of just building plain CRUD form. So the application feels more like a real internal management platform rather than a basic tutorial project. Next, I will talk about the engineering challenges, deployment problems, and the trade-offs I faced while building the system. Coming to the engineering challenges and trade-offs, one thing I really enjoyed about this project was that it exposed me to the real engineering problems beyond just writing features. For example, deployment itself became a significant learning experience. I deployed the backend on render and used managed Postgres with Prisma migration. During deployment, I ran into database connectivity issues, environment variable mismatches, missing dev dependencies, Prisma enum migration conflicts, multi-part upload failures. And honestly, debugging those production style issues taught me more than building simple CRUD APIs. One major issue involved Prisma role enums. At one point, old migration still reference the outdated enum values while the schema had already evolved. That caused shadow database migration failure there during deployment. To solve it, I had to reset migration locally and rebuild a clean migration history aligned with the final schema. That experience really improved my understanding of schema lifestyle management. Another challenge was cloudinary uploads. The backend expected multi-part form data with a specific field name, while the frontend initially used a mismatched field. That caused a request.file to become undefined inside Multer. After tracing request payloads and my backend logs, I fixed the upload pipeline and standardized the attachment handling. I also made the intentional trade-offs in architecture. For example, I used JWT tokens stored in local storage for simplicity and faster integration. But in a stricter production environment, I would move refresh token into HTTP only cookies. Similarly, I avoided over engineering with repository layers because for this project size, direct Prisma usage inside services was still maintainable. I tried to balance scalability, readability, deployment speed, and production realism. Another trade-off was analytics calculation. Currently, dashboard metrics are computed client-side from fetched task data. That's perfectly fine at this scale. But if this system grew significantly, I would move those calculations into an optimized aggregation endpoints or caching layers. Finally, let me talk about scalability and how this architecture would evolve further. From a scalability perspective, I designed the system to evolve incrementally instead of locking it into a rigid architecture. Because the backend is stateless, it can already scale horizontally behind a load balancer. The database schema is relational but modular enough to support organization level workspace, advanced permissions, notifications, audit logs, analytics, and real time collaboration. If I continued building this further, some improvements I would add include Redis caching, WebSocket based real time updates, backend. Additionally, I would add activity feeds, CI/CD pipeline, or centralized logging. I would also strengthen authentication with refresh token rotation, token revocation, session tracking, rate limiting, and more advanced security policies. Another future direction would be microservices. Right now, the monolithic backend works very well for this scale, but over time, attachments, notification, analytics, auth could be extracted into independent services. Overall, this project gave me hands-on experience with full-stack architecture, backend engineering, RBAC system, database modeling, API testing, deployment workflows, cloud integration, debugging production issues, and scalable application design. And honestly, that was the main goal. I didn't just want to build just another portfolio CRUD app. I wanted to build something that actually resembles a real engineering system with practical architecture design and real operation challenges. Thank you for watching.